Well, welcome to my YouTube channel Know About Embedded System. In today's video, we will discuss some of the interview questions on Embedded C. So this is the second series of Embedded C interview questions. In the previous video also we have discussed some of the interview questions, and today also we'll discuss some questions on Embedded C. So before starting the video, so if you are a newbie to my channel, kindly subscribe my YouTube channel and gain the knowledge on Embedded System. Let us start the video here. So today, in the previous video, we have discussed 4 embedded C questions, and today 5th one we will discuss. So today's first question is, what is a recursive function and how it works? So this is also one of the important question. In most of the interview, we will get this question. What do you mean by recursive function and how the recursive function will work? So what do you mean by recursive function? Recursive function, basically calling a function to itself, is called as recursive function. The function will call itself is called as recursive function. How it works, that I'll explain you later. So in recursive, so there are 2 parts will be there. One is called base case testing and one is called recursive case testing. So what is this base case testing? So why we require this base case test? This is very important. Everyone should understand why there is a base condition or a base case test in the recursive function. So if you're using a recursive function, the function will calls itself, and it will go on calling itself continuously without end. If there is no end, or if there is no condition to stop the recursive, it will enter into infinite loop. This is a very important thing we should know. Recursive functions will enter into infinite condition, and that is going to result in a stack overflow. So there should be some end point, and that end point is nothing but base condition. So if you are not providing a base condition, your recursive function will enter into infinite loop and it will result in a stack overflow. So that's why there are 2 important things we have to do. One is a base condition check and one is a recursive condition check. So base condition is nothing but it's a termination condition. So we have to provide a termination condition where your recursive function will end. That is the first point. And if there is no, if your function is not meeting with a base condition, then it will jump to recursive case. In this case, your function will call itself and it goes on calling itself. So when it reaches to base condition, it will terminate. So this is how the recursive functions will work. So in the recursive function, so we have to understand how it works. So that is also very important. So when you are calling a recursive function, internally the compiler will create a stack for your recursive functions. Right? So when recursive function is called, a new stack frame will be created in the memory for each instant. This is very important. For every one call, it is going to create one stack. You can see here, I have 2 stacks for 2 different instances. Okay. And here in this stack, it is going to store some of the local variable and return address both. So this is the second thing you should understand. Third thing is, what are the different things will be there in the recursive call. So one is called function call, nothing but a recursive function call. This is the initial call for the function. When you call the first time, this is called initial function call. The second one is a base condition check. I have already explained what is a base condition check. So if you do not provide a base condition check, your function will enter into infinite loop, and that is going to create a stack overflow. And then recursive step is nothing but function calling itself, and continuously it is going to push the variables into the stack like this. That is called third point we should understand. And fourth point is, whenever your recursive function or whenever your recursive call meets with a base condition. So whenever your recursive function call meets with a base condition, then your recursive call will be stopped and it will start unwinding the stack. That is called as unwinding the stack. So whatever stacks it is created, one by one it will unwind. It will fetch, or it will restore the contents. It will take the content from the stack, such as the local variables and return address and so on. and when it ends with the last step, it is going to produce a final result. So until initial call completes and final result is obtained. So till this, it is going to unwind and it will produce output. So this is how recursive functions will be working. If in the interview, if they ask you to explain, you need to explain at least this part to get an impression in the interview. So one programming example also I have taken here for a recursive function. So recursive function, the best programming example is factorial of a number. So factorial of a number is one of the best example for recursive function call. So program, you can see this is my main code. Yeah, so this is your main code currently what you are seeing. This part of the code is called as a main code. Here I'm assigning the variable called as a 5 here, number 5, and here I'm calling the function factorial number what you're seeing here. This is called the function call. I'm calling the function and also I'm printing the factorial of a number. So now when you call the function, so your control will be jumped to the function called as here. It will jump to factorial of a number here. At this point, it will jump. Your control will jump to the factorial of a number here, and this is your the factorial of a number design. According to our recursive function, the first point is base condition check. You can see here the base condition, which is going to stop the recursion when n is equal to 0 and 1. So what is the factorial of 0 and 1? Factorial of 0 is 1 and factorial of 1 is also 1. So this is my base condition. If your function meets with n is equal to 1 or 0, it will stop and it will retrieve the stack content. Or else, this is called recursive case. This is my base case and this is my recursive case. In case of recursive case, I'm going to call the function once again. You can see here, return n into factorial of n minus 1. So again, I'm going to call the same function, whatever I called before, or within the same function, I'm calling once again. So this type of functions are called as recursive function. I hope this is clear to all. You can take this example, and in the most of the interview also they will ask you, can you be able to write one simple program to find a factorial of a number using recursive. So this program is also very important. Let's move to the second question of today's session. What is the purpose of volatile keyword? What is the purpose of volatile keyword, or what is the use of volatile keyword? See, in our microcontroller, when you're dealing with the microcontrollers, we'll be having a different registers, and these registers will get a data updated for every microsecond and millisecond, irrespective of the software. In that situation, we have to use a volatile keyword, variable with a volatile keyword. So the volatile keyword in C programming is basically it's a qualifier, and that tells to the compiler that variable value will change at any point due to external factors. This is what I told you. So volatile keyword is used to the variables where data is changing very frequently. Okay, that is the first point. And second point, this directive, this volatile keyword will also tell to the compiler to not apply optimization technique to these variables, to avoid applying optimization techniques. So when you optimize the coding, sometimes your variable may lose the updated value. So that's why these two points are very important. The next, where we will use these volatile keywords, I have already told you in our embedded system, most of the registers, especially the status registers, you can see here this point. So most of the time status registers will get updated in a million microseconds, irrespective of our code. From the microcontroller hardware side, the registers will get updated. So whenever our flags are updated or registers are updated, so we have to read those to from the variables. So those type of variables, always it should be volatile. And second scenario, these volatile keywords are used in the interrupt service routine execution, or whenever you want to update your variable in all the functions, including interrupt service routine, including function calls, including your main program. So in that situation, we will use volatile keyword or volatile variable. Okay, so I hope this answer is clear. So we can use very simple it is. We have to use a keyword called as volatile. That's it. Volatile integer, volatile float, or volatile character, something like that. Next one is, what is the purpose of const keyword in embedded C programming? So this is also one of the important question. The const keyword is going to it's going to tell to the compiler that the value will not change or will not be alterable. I'm going to define one variable and I'm going to initialize some value to that, and that value should not be changed in future. Declaration and definition will be done only one time, and its value should not be changed again. So this is called as constant. So best example is your pi. So whenever you're defining with a pi value, what we'll do, so we will use like const float, something like this, float pi 3.14, indicating that the pi value is always 3.14, and that's going to be constant, and it is not allowed to change it. That's called as constant value, and it is not allowed to change. Okay, I'll show you one example here. So now you can see this is a small programming snippet I have taken. This is what I have shown you already. So constant float pi, right? So you can see here constant float pi 3.14. This is a pi value constant. And one more example, constant const integer max user is 100. I'm going to print it. Now if you're trying to change, let us assume after printing some value I want to change it. Now you can see attempting to modify the const variables will cause a compilation time error, saying that the assignment of read-only variable pi. So that means pi is assigned as a constant, defined as a constant. That value is not allowed to change. So this is how we will be using const keyword. Okay, I hope this is clear. So next question is, what is the difference between static and auto variables? Static and auto variables. So guys, these static and auto variables are storage class specifiers. So what do you mean by storage class specifiers? Storage class specifiers will define the scope of the variable and where it's going to store in the memory. Okay, these two important things it is going to define in the storage class. Let us understand one by one. First we'll understand about the auto storage class. What do you mean by auto storage class? Auto storage class is nothing but it's a default storage class which is available in the C programming. You can see here auto variables or auto storage class. So before that, the storage, what do you mean by storage class? Storage class means it is the storage classes are going to specify the scope, lifetime and initial value of the variable, right? So what they will define, they're going to define the storage classes will define scope, lifetime and initial value of the variable. Okay, now so if you consider auto variable, we have to use actually we have to use a keyword called as auto, and it's an optional one. Here you can see, so this is one of the default storage class which is available in a C programming. We have to use either auto or but even if we don't use also no problem. What is the scope of this variable, this type of storage classes? The scope of the storage class within the braces, nothing but, and where it will store in the stack. So where it is going to store, it is going to store in the stack uninitialized variables. Okay, it is going to store in a uninitialized data. And what if you do not initialize your auto variables, it will take a garbage value. What is the default value? Default value will be garbage or uninitialized value. So this is all about auto storage class. This is next one is static variable. What do you mean by static variable? The static variable, this is also one of the storage class available in the C programming. Where this will be, first I'll explain where it will be used, and later I'll discuss what is the scope and all. The static variables are used whenever you want to keep your data live. Whenever you want to keep your data live, even in a multiple functions. Whenever you move the variable in a multiple functions, still you want to keep our data live and updated properly. In that situation, we will use the static variables. It is useful for counters that need to be maintained their state between the function calls. This is what I told, right? So static variables are going to keep the value updated even if you move to the even if you go and execute in another function as well. So in such type of application required a static variable. And what is the default value for these static variables? The static variables, it will take a 0. Okay, this is going to take 0, and it is going to save the data in the DSS of your data segment of your stack, initialized data segment. Okay, and we have to use the keyword called as static. So we have to use a static keyword. Okay, and scope will be throughout your main program. So throughout your main program, your static variable will be running. So you can see this point. So what is the advantage of this? The lifetime of this static variable is it is initialized only once, and its value will be retained across multiple functions. So this type of variables are called as static variables. So I have one example here. With that example, we will try to understand. So this is my main code. If you observe, let us see here. This is my main code. This part is a main code, and this is my one function called as a function test. Okay, I have two parts here, main program and your function test. In the main program, what I will do, I will call the function called as a test function. Twice I will call here. So when I call first time, it is going to print variable a is equal to 1 and s is equal to 1. So that means a stands for auto, s stands for static. So a and s both are initialized to 0 first time, and when I increment a plus plus and s plus plus, it will print as a as 1 and s as 1. This is first case. And when I call the same function second time, a will be initialized to 0 once again, and it will increment as 1, and s will not initialize to 1, initialize to 0, because it is going to create only once. So try to understand these two sentences here. The recreated and reset to 0 every time auto variables. So auto variables will be recreated and reset to 0 every time. But in case of a static case, it is created only once and initialized only once, and its value will keep updating every time when you call the function. That is why whenever you call the second time, output of auto variable will be 1 and output of your static variable will be 2, because it will initialize only once. It will increment in the first time. It will also increment in the second time with the updated value. So this is how you can differentiate both auto and static storage classes. Okay, so I hope this video is informative. If you feel this video is an informative video, please click on like button and subscribe to my YouTube channel.